So hello everyone. I hope everyone's still awake today. Long day, cool conference. I hope everyone's cool. Today I want to talk about optimizing Snapshot, enhancing Solana's node sync scalability and performance. So I hope everyone is ready. We have some cool things to show. The current situation. The current validator client downloads a snapshot, for everyone that doesn't know, downloads a snapshot somewhere from the network, hopefully from a trusted source, and tries to actually sync up with the network. This is currently done by peer-to-peer connection, which is not bad, but there is some challenges with it. There is no CDN support. There's no way of distributing snapshots really well. So that can be a problem. It also has a high cost relatively. Solana nodes are not cheap and bandwidth is not free everywhere in the world. So that needs to pay for. For this to actually work, you need your RPC node to open, for your node to open an RPC port. And an RPC port, everyone knows, is like kind of bad, you know. You open RPC port to the internet and there's people scraping your nodes as fast as possible, which is not great. The catch-up times in some regions are really slow. Currently on mainnet, we have like 95 gigabytes of snapshot that needs to be downloaded. If you have a node in Asia, you want to download from a trusted source, sometimes it's so slow that you need to download a new snapshot because the old one was basically already too old to use, which is kind of bad. So what kind of problems we face? Well, I already said it a little bit. Hardware costs for Solana is quite high. And basically, if you want to run a validator, you don't want to open everything to the network, right? So basically, if you want to host a node that also distribute snapshots, you basically need to run another node, which is costly. There's no way of CDN type of delivery. So if you want to download from a source, it needs to be peer-to-peer, and there's no way to maximize like leveraging already existing protocols or technologies that can make it faster to download data, because that's actually what it is. And there is no trust model around snapshots. You hope that the snapshot you're downloading is right and that no one tampered with or actually exists. HTTP GET, which can be slow. There's better technologies that can make downloading information parallel, faster, etc. And you cannot resume and verify or optimize any download. So basically, if you try to download with your validator a snapshot, it can just stop halfway through because, well, that file is deleted on the node at the other end. And well, yeah, there you're stuck with no snapshot and really long sync times. Well, here's like an example of like something that would be really slow. But why does it matter? No, I'm standing here speaking to you all. I'm like, why does this actually matter? Well, if you start a validator, starting it would be fine if that's a little slower because you're starting out. But imagine your validator is broken and you need a new snapshot and it takes hours or sometimes like it's in an infinite loop of downloading a snapshot and your validator actually doesn't come online. That means you're losing rewards, right? You can have like great API, but your validator need to actually run for it. Sync failures, we see it in Discord a lot, that people I'm trying to launch my validator, it never catches up, it's like a billion blocks behind. How's that possible? Most of the time it's like it was a snapshot that actually didn't work and it tries to sync from something really old. What is also really interesting, Blockdaemon has a lot of nodes, so are Helios and Triton, they have all a lot of nodes. Like operators think like, okay, how can I use this for myself? And basically everyone reinvents the wheel and makes something new. So everyone solves it for themselves, but not for the community or for smaller operators or people that has just a single server. Well, I don't know how much people actually run nodes or a validator, but there are sometimes that the network stalls and you need to snapshot, right? And what happened in the past is that you can generate a snapshot from your local state, and sometimes that fails and everyone's like, okay, I need a snapshot. And basically someone is saying, yeah, I uploaded somewhere here on the internet, good luck with that. And you basically, I kind of need to trust them, hopefully if it's a good one, and maybe it's even the wrong one. So it could help with, also it congests because everyone downloading from the same source will make it really slow. Also, again, geographically, if you're in Asia, you want to download something, most of the time it's not that fast. Also in Australia, downloading a snapshot, well, I would say really good luck. So one does not simply download the Solana snapshot fast. And then you think, well, hold on a minute, how does it actually work? The current architecture works like this follow. We have like a validator that has exposed RPC and allows other people to download a snapshot from their validator. In Gossip, you have like the validator that advertises itself. So other validator knows that that's a place you can download the snapshot from. And the snapshot traffic is baked into the traffic of the network or the validator itself. The limitations is like, well, the snapshot hits you download it from a live validator or from a live RPC node, and it can use its bandwidth for other stuff, probably something more useful than serving snapshots, right? So there is no incentive for anyone to actually allow snapshots to be downloaded from their validator. And a robust fallback, it tries to download a node and a snapshot, and it tries again, but it has its own rules on what it tries to download. This is currently what it looks like. It goes somewhere and sometimes cannot find it. Sometimes it takes really long to find actually a snapshot, which then is really slow. The workaround. So people had the same problem for a long time, right? And then basically what the official documentation says is, well, you just download a file from like a trusted source you think is trustworthy with wget or curl or something. So hopefully that's something. And then other people are like, I want to automate that a little bit. So there's a snapshot finder that goes out to the whole network. It goes to Gossip, finds all the nodes, and then kind of abused all of those nodes because it tries to download some file. And if it fails, it says, this is not a good provider. And if it's fast, basically it eats up the bandwidth of the user. And everyone keeps doing that. Well, you can imagine that's not great for your infrastructure. I rewrote it in Go some time ago, and I was like, well, this isn't a great solution either. For a larger operator, it makes sense to actually transfer snapshots from one node to the other because we have direct links and it's really fast. So it looks something like that, snapshot net found. This is like the snapshot finder thing that actually destroys the network by finding snapshots. So at Blockdaemon, we thought, well, how can we serve the community a little bit better than just nuking the network and try to find a good source, is to come up with this solution that's more scalable, doesn't require a lot of changes in the ANSA code or like the validator code. It needs to have kind of CDN-like properties, so put the snapshot on a fast storage solution, have it fully decoupled for validator, right? We don't want the validator to have open ports, and well, at least amount of changes for anyone that wants to use it. So we come up with something that looks like this. So we'll go into a little bit deeper on how that looks like. But it basically has a couple of components. The first one is a snapshot sidecar, is an uploader. So your validator is making really great snapshots, incrementally or full snapshots. And we can use a program that actually uploads all the data to some data storage. So it could be anything. Currently, the solution, we already built something, and I'll show this a little bit later. We have a lightweight gossip client because the full validator client is quite expensive to run. So why not make a simpler client that only serves for snapshot distribution? And optionally, we could make a reverse proxy that can do any rules you want. So the sidecar. This is really basic what it looks like. You have like a Golang program in a container or as a service that runs alongside the Enza like validator client. It looks for the Genesis file and snapshot files and uploads it now to S3 bucket. Because S3 is easy to integrate, it's widely adopted and it's widely available. So for now, it just uploads to the S3 bucket. It runs outside of the snapshot or outside of the validator code itself. So it can be restarted. You can do everything you want with it. And it reduces the load on the validator. We already implemented an MVP that actually can do a lot of things. It has like smart finding the right snapshot slot and the feature set and version and everything else. It makes metadata about the snapshots. And it uploads to the S3. It's also scalable. So as a provider, you can run multiple of these instances and it will upload not the same snapshots over and over, but it's smart enough to see, oh, someone is already uploading this snapshot, so I'll skip it. Then comes the interesting part, in my opinion, a lightweight gossip client. It is based on the ANSA code, so it's written in Rust. It responds to calls that are necessary for the validator to download the snapshot. So to get a slot, and there's a couple of other requests it does. It automatically acts as a validator client, but is not actually validating anything. But it helps the validator to see it as a download client. It separates, so in order for this to work, you can run it outside of any validator node. You can run a little GCP machine or somewhere your Kubernetes cluster or a machine, a VM, wherever you want, and act as a validator, and it can run there and redirects the downloads from the light gossip client to the actual client. So it's easier and cheaper to run. You don't have to run a full-fledged node anymore. And we have some cool identity keys with the SSDN. So basically you can make it easier for people to differentiate which is a light client and which is not. We actually have this code as well. We are still working some kinks out, but actually the full setup, we got it working like a few days ago from end to end. So it's pretty cool. So for everyone that wants to take a look. Reverse proxy. So a lot of operators and people know what a reverse proxy is and how to work with it. We can also choose to not use the light gossip client, but use a reverse proxy to have the same kind of idea. But you still need to open some information on the validator machine, but you can isolate it to only the reverse proxy. So that's also an option. No extra required infrastructure to be run than just the validator that already exists. Optionally, this can also be a sidecar to the light gossip client itself. because you can do some black magic with reverse proxies to redirect traffic or to multiply traffic. The MVP, so we call this an MVP because it is something that works, but we haven't tested it out in the wild, and there's not much people that actually use it yet. But we want to the network and everyone that has a validator or RPC machines to eventually use it and see if it's something they can work with. So we call it an MVP because it's not really well used yet. So the CDN or a storage server is the first thing that we wanted to implement. So the snapshot uploader already exists. We have now an S3 bucket in R2, which is Cloudflare. Ingress and egress is quite cheap, and the API calls are quite cheap, so we can run it there. We have the gossip advertisement via the Light client, and we have no need for any Solana changes. So this can run outside, and you could point your validator towards our gossip client, and we'll just download Genesis files, snapshots, etc. as normal. We don't really use the reverse proxy yet, but we could in the future. Long-term vision. So the long-term vision is more or less maybe use HTTP 3 or quick support, right? Because it's just a large file, and yes, it needs to be fully built, but there are technologies that are faster. So maybe HTTP 3 with streaming, or quick with streaming, or a BitTorrent style of client that can actually make peer-to-peer connections, but only for snapshots. Maybe something for snapshot verification, right? We now generate a hash of every snapshot that is uploaded, so you can verify that's actually the snapshot that's uploaded and downloaded from a specific source. There's currently no trust or incentive model, so still there's no one that actually is incentivized to use this or to run this because it costs money. But at some point, maybe there could be a model behind it. And multi-threaded and reusable downloads is something we want to look into as well. Currently, the uploading side can do chunk-based uploading, so it can be resumed, etc. The download portion doesn't work for that fully yet. Also, the snapshot data is actually really useful for archival and full history kind of deal. We could actually improve hosting large amounts of snapshots over time if we wanted to. And in the end, we actually want it to be integrated in the ANSA code, right? If we can improve it, this new way of downloading and distributing snapshots, it should be part of the ANSA code, and it should work out of the box. So in summary, validators shouldn't have to serve snapshots, right? We could offload that to the new infrastructure. We can have a sidecar, a light gossip client, and a CDN to do all that work for us. We don't need the ANSA to be the distributor of snapshots because it's just a large file. MVP doesn't require Solana upstream changes, which is great. The architecture enables long-term support, right? Even if we never integrate in the ANSA code, we can actually run this alongside it for however we want because there is no dependency. And there's faster speeds and less served regions because we can just choose to upload it to some data storage there. So hopefully you see greater even than a gigabit a second, of course. That was it for me. I'm a little short on time, or long on time. But does anyone have any feedback, ideas, or see any problems with this approach or solution? Happy to hear it. Or maybe you're sleeping because my talk was not that interesting. It's also fine. We here have the QR codes again for anyone that wants to check out the repos on GitHub that we opened, and if anyone wants to talk to me outside of this, there you go. Cool. Guess that's mostly for me, if there's no any questions. Okay, thank you, I guess.